Unit 10, Lesson 4, Finding Trig Ratios Using a Ratio. Our goals are going to be using properties of trig ratios to determine an angle's location on the coordinate plane and finding the remaining ratios. So we talked a little bit about graphing angles on the coordinate plane. We know we have our 0 degrees, which can loop around to 360. We have 90 degrees, 180, and 270. And so when we think about the coordinate plane, we know our x values in quadrant 1 are positive and our y values are positive. So in quadrant 1, they're both positive. Quadrant 2, we know our x values are negative and our y values are positive. In quadrant 3, the x and y's are both negative. And in quadrant 4, they're positive for x and negative for y. So when we go ahead and do our different trig ratios, we already know that sine, we saw earlier, is basically your y coordinate over the hypotenuse, which I'm going to call r. Cosine is the x coordinate over your r, and tangent is your y over your x. And so what ends up happening when we calculate these ratios, it actually works out that in our first quadrant, we can see here from 0 to 90, that's really what we're looking here, 0 to 90, what's going to happen is our sine of theta is always going to be a positive number, cosine of theta is always going to be positive, and tangent of theta is always going to be positive. So in this first quadrant, all three ratios are positive. And then obviously the reciprocals are going to follow suit with those same properties. If we look at quadrant number 2, that goes from 90 to 180, again, if we use these properties here, since our y values are positive here, sine is actually going to be positive in this quadrant. Cosine, since x is negative, is going to be a negative, and tangent is going to also be negative, right? So we're going to find that in quadrant number 2, your sine is going to be positive. And in quadrant 3, again, that goes from 180 to 270. Since they're both negative, we actually know sine and cosine are both going to be negative. So sine is negative, cosine is negative. And then your tangent, since it's y over x, is going to end up being a positive. So in quadrant 3, tangent is positive. And then finally in quadrant 4, we're going from 270 to 360. And in this quadrant, we're actually going to have that since the x values are positive, only cosine is going to be positive. And the rest are going to be negative. So in this fourth quadrant, only cosine is positive. And so we like to use, there's lots of phrases to do it. I'm going to use the phrase, all Slurpees taste cold. To remember that in quadrant number 1, they're all positive. In quadrant number 2, sine's positive. In quadrant number 3, tangent's positive. And quadrant number 4, cosine's positive. There's also the phrase, all students take calculus. I'm going to use all Slurpees taste cold. But either way, that helps us remember the quadrants. So it's all Slurpees taste cold. So that's all positive, sine positive, tangent positive, cosine positive. In the first examples, all we're doing is simply stating what quadrant the angle lies in. So when we look at this, first I'm going to set up the same thing. I know quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And I'm going to write my little acronym. So all Slurpees taste cold, right? So in quadrant 1, they're all positive. In quadrant 2, sine's positive. In quadrant 3, tangent. And in quadrant 4, cosine. So in this one, it says sine is greater than 0. So anything that's greater than 0, that means sine is positive. And So if sine's positive, it can be either quadrant 1 or quadrant 2. Right, so either they're all positive or sine's positive. And then they tell us cosine is less than 0. So cosine, anything less than 0, that's saying it's a negative. So what that tells us is it can't be quadrant 1 because everything's positive in quadrant 1. So where's cosine negative? And that's going to be quadrant 2. So our answer for this one would be quadrant 2 because we know in this quadrant sine is positive, but cosine is negative. In example 2, same thing. So we have here a few things. We have tangent is greater than 0. So that's basically saying tangent is positive. We have cosecant is less than 0. So that's negative. And remember, cosecant is the reciprocal essentially of sine, right? So that's like saying sine is a negative. So really that reciprocal tells us the sign of the original function. So now when we look at our quadrants, I'm going to do the same thing. So all students take calculus or all Slurpees taste cold. And I'm looking at where tangent is positive. So that could be either quadrant 3 or quadrant 1. But we have that sine is negative. So we know it can't be quadrant 1 because there's no negatives allowed in quadrant 1. So this would be an example. It's in quadrant 3. And that would be your final answer. And then finally, the last question is for cotangent. Cotangent less than 0 is negative. So cotangent is the reciprocal of tangent. So tangent would also be negative. And then cosine would be positive. So if we go ahead and look at that, we know it can't be quadrant 1 because they're different signs. And again, all Slurpees taste cold. We're looking for where cosine is positive, but tangent is negative. So this would be quadrant 4. For the second topic, we're using those angle restrictions now to get all the trig ratios. So this is kind of just putting together what we've already been doing. So a few things, they give us sine is 3/5. So right away we know cosecant is 5/3. And this is very similar to what we saw in the first section. The only thing is now we have negatives and positives. So we have to kind of figure out what quadrant everything's lying on. All right, so we know that in this case, they tell us cosine is negative, right? So we know that our sine is positive, but cosine is negative, so they're different signs, so we know it can't be in quadrant 1. And so it actually is going to be living in quadrant 2 because sine is positive. And so a few things we know here. So if sine is positive and it's in quadrant 2, that means cosine is negative and tangent is negative. So I'm actually going to put those little signs there. So I remember that the other ones are all going to be negative. I can then draw my little reference angle. And sine is 3/5. So if I remember SOHCAHTOA, my opposite side is going to be 3. My hypotenuse is 5. I have to find, I'm going to call that x for now because that's my x value. I have to use Pythagorean theorem. And we're going to get 4. And then this is my adjacent, my opposite, my hypotenuse. And so my adjacent is going to be 4, but really remember it's a negative cosine. That's why putting those signs in the beginning is kind of nice if you want to put a negative to remind you. So it's actually negative 4/5, and this will be 5/4. And then tangent would be 3/4, but it's actually a negative 3/4, right? And then this would be negative 4/3. And that would be your final answer. For this last example, that's actually a negative radical 5/3. Same thing. So I'm going to go ahead and first figure out what quadrant we're in. So I'm going to put all Slurpees taste cold. Cosine is negative. Negative 5 root 5/3. I already know secant would be the reciprocal. And I might rationalize at the very end. So I also have cotangent is positive, which also means that tangent is positive. So I see they're different signs, so it can't be quadrant 1. So it's actually going to be quadrant 3. So something like this. So I'm going to have this little reference angle that I'm going to use. And so when we label this out, we have SOHCAHTOA. And they tell us cosine is negative root 5/3. So that means my adjacent is root 5. And then my hypotenuse is 3. Actually, I labeled that. Let me fix that. So we have root 5, and then the hypotenuse is 3. If you want to put a little negative to remind yourself, you can, but again, we're going to kind of fix it up in a moment. So if it's in this quadrant, we know that tangent is positive. So these are both going to be positives. We also know in this quadrant, tangent's the only one that's positive. So we know sine's going to be negative. So if you want to put those signs in the beginning so we don't forget. And then we need to do Pythagorean theorem to get that other leg. So when we go ahead and do Pythagorean theorem, we're going to get y. We have y squared plus negative root 5 squared, or you could just do root 5 squared. We'll just treat it like a positive. Equals 3 squared. And we're going to get 2. And so now the sign is going to be 2/3. So it's actually negative 2/3. That's why it's kind of nice putting the sign there in advance. Cosecant's negative 3/2. And then tangent would be 2 over radical 5. Or radical 5/2. And then the last step would be to rationalize. So we have to rationalize tangent, which is positive, and secant, which is negative. So negative 3 root 5/5. And 2 root 5/5. And then this would be your final answer. If you have any questions, you can ask in class, sign up for T-Will time, or go to the center.